Exponential functions from written description. So it says Keisha's podcast covering the latest news in the music industry has recently gained a lot of popularity. She started off with 30 active listeners, but each month it has doubled. Write an equation to represent the number of active listeners Keisha has, y, and each month it's doubled. So I'm going to write y equals 30 times 2 to the power of x. That's in the form of the y equals a times b to the power of x for exponential functions. B says create a table and graph to represent the relationship. So I could start substituting these values in for x. Remember, x is our months. So if I substitute 0, 2 to the power of 0 is 1. 30 times 1 is 30. 2 to the power of 1 is 2. 30 times 2 is 60. 2 to the power of 2 is 4. 30 times 4 is 120. And I could keep just substituting these values in, but keep in mind the growth factors too, right? So the pattern should be multiplying by 2. So I know this can be 240. I know this can be 480. And then that would be 960. So I'm going to graph it. 0's at 30. 1's at 60. 2's at 120. 3's at 240. And I'm just kind of estimating here. 4's at 480. And 5's at 960. Okay. All right. Did my best there with that curve. And these curves aren't always going to look wonderful since I'm kind of estimating their spots, right? This says at this rate, how many active listeners will Keisha have after 7 months? So you could continue the table to figure that out, or you could use the equation. I'm just going to use the equation. But you could do 6, 7 and use the table and just keep going. But I'm just going to use the equation. So I have 30 times 2 to the power of 7. So 2 to the power of 7 is 128 times 30. I got 3,840 active listeners. Okay. D says, if her podcast continues to grow at this rate, how long will it take for her to have more than 30,000 listeners? So this, we're trying to figure out when we can get to 30,000. So you could start guessing and checking, but I'm going to continue the table. Now, maybe I should have done that earlier. Let's see. Okay, so it's 6. It keeps doubling. So 960 times 2 times 2 times 2 times 2 times 2. At 10. 10 months. And there's other ways to figure that out, but I just felt like doing it with the table. So you could have just started guessing, plugging stuff in, like you could have tried 9 by plugging in 9 with the equation. But I just decided to continue the table, and I figured at 10 months. All right. On number 2, I'll let you do. So remember, you have to figure the pattern here. It's giving you the table, so you have to figure the pattern here. It looks like it's dividing by 3, or in other words, multiplying by 1/3. And you could always divide to figure that out. But I'll let you do 2. I'm going to do 3. It says, in an effort to be healthier, Jamar is reducing his sodium intake by 13% each week. Jamar measured his current weekly intake of sodium to be about 28 grams. Write an equation to represent the amount of Jamar's weekly sodium intake, y over x number of weeks. So I'm going to say y equals 28, that's what we're starting with, and reducing by 13%, so I could write 1 minus 0.13 to the power of x. That could be my equation. But I'm going to simplify this up a little bit. I'm going to write y equals 28 times 0.90, oh, not 97, 87. 1 minus 0.13 would be 87 to the power of x. And that's the equation I'd rather use. So, week 0 is 28. So I don't even need to plug 0 into that equation. I could. 0.87 to the 0th power is 1. 28 times 1 is 28. And I could keep substituting those values in. 0.87 to the power of 1 is 0.87 times 28 is about 24.36. I could substitute 2 in there, 0.87 to the power of 2 times 28. I got about 21.19. And I'm just going to, for this, I'm going to round to the 100th place. And then I could, again, plug in 3, 0.87 to the power of 3 times 28. I got 18.44. But remember, the rate is 0.87, so I can just keep multiplying by 0.87. So times 0.87. Times that by 0.87. Times that by 0.87. Times that by 0.8. Crap, I accidentally pressed the wrong button, so I'm just going to use the equation 0.87 to the power of 7 times 28. Okay. About that. Now, here's the thing. This is a decay, right? It's obviously decaying. He's reducing his sodium intake. I wouldn't say it's an issue, but the weird thing is when we graph it, it's going to be such a slight exponential function. It's going to look a little funky. But, exponential function is not always going to be so dramatic in terms of its decay. Sometimes it might be slight, but here we go. So 0 is at 28. 1's at 24.36. So, I don't know. 21.19 for 2. So about 21. That'd be around here. 18.44. So 19's there. 18.44 maybe here. What am I at? 4? 16. Pretty much exactly on 4. 16.04. About on 16 there. 13.96. That's basically 14. 12.14 for 6. We'll just go barely over 6. 10.56 for 7. So maybe there. 9.19 for 8. Barely there. So if we connect these, you can see kind of a curve. A little bit. It's just the ever so slightest curve, right? It's a slight curve because it's only a 0.87. It's not a dramatic cutting in half each time. It's just a decay of 13%. So you're not going to see anything so dramatic with that. But yeah, that's what the graph would look like. C says if Jamar decides to stop his diet after 10 weeks, approximately how many grams of sodium will he intake on his final week? So on the 10th week, let's substitute 10 in here. 28, 0.87 to the 10. 0.87 to the 10th power times 28, I got about 6.96 approximately 6.96 grams of sodium. Okay. All right. Let me just help you out a little bit on this one. So you can plot the points and graph it. But for B, what percentage is the town growing each year? Remember, you can just divide. I'll kind of tell you what to divide. Divide the 14,790 divided by the 14 by that, and then get that answer. I'll just do this because I'll just do that for you. So 14,790 divided by 14,500, and you get 1.02, which means a 2% growth. Whoops. Okay, so that's 2% growth. So, yeah, and this graph is going to be hardly a curve at all because it's a 2% growth. So it's when you graph it, it's going to show just the slightest little bit of growth there. Okay, so you try number 4 and go back and do number 2 as well.